Hey everyone, and welcome to Security Live. Security Live is a show focused on AWS and AWS security partners, solving challenges for our customers. And you can find us on Twitch, YouTube, and LinkedIn. And every show we bring on an AWS partner and we discuss various topics related to security. And you can tune in every other Tuesday at 8 a.m. Pacific time. Very hard word for me to say, and 4 p.m. GMT time. And don't forget, if you wish, please join us in the chat stream and ask questions to our partners. My name is Margo, and I am one of your co-hosts. I'm a security and compliance specialist SA with AWS. And Rob?
Hey, good morning, good afternoon, possibly good evening. My name's Rob Hale. I lead AWS's partner security business in EMEA.
And Rob, are you just back from Beers and Bradwurst? Security, beers and Bradwurst.
I am. It was great actually. So back from Hamburg. If you called us last week, then you'll have seen 11 separate AWS Security Live segments. So we had 10 guest partners and an AWS speaker as well. Some amazing guests. Love Hamburg, brilliant city. National Asparagus Week apparently last week. So yeah.
Beers and asparagus. It's a bit of a dangerous thing. Okay, so please join us in the comments. Tell us where you're joining from and any questions for our guest today. And today we have Aqua Security joining us, and we have Tsvi Korren, who is the field CTO from Aqua Security. And Aqua Security is the pioneer in securing AI and containerized cloud-native applications from development to production. And they provide solutions at each of those milestones from multiple milestones through the life cycle. And let's see now if we're having security not so live issues and getting Tsvi online and joining us. Hey, welcome. Perhaps you can do a better job than I did there introducing yourself.
Hey, Rob, Margo. Thanks for having me. Glad to be here. So yeah, I'm the field CTO of Aqua, and as you said, Aqua has started around 9 years ago when Docker containers started to emerge in the industry. And our job is to secure them. So we secure containers, cloud-native applications in containers, in functions, in Kubernetes. So if you hear any of these terms and you're wondering how to secure us, probably give Aqua a call.
9 years ago, is that that feels like a long time ago. It's all changing.
Yeah, honestly, I don't even remember what happened before 9 years ago. But I've been in security for about 25 years now. I started in the tail end of the last millennium. The reason is that I just found a job in a security startup, and I just got into security ever since.
Do you remember we used to say that like servers were like pets and you give them names? And then I think, well, what was it we used to say about containers? That containers then were like cattle, which if you're vegetarian isn't a great analogy, but there was like this, I do remember this about 10 years ago, this trending in conferences, people talking about your server.
Yeah, absolutely. Yeah, one of the things that's interesting about containers that you really don't manage them individually, right? You manage them in groups, you manage them in deployments, you manage them in scale sets. So unlike the server that was probably in your basement and you gave it a name and you uploaded the software onto it and you manage it over time and patch it over time, containers come and go. And there are some really interesting methods on how to secure them and how to build them securely.
I did have one.
So you feed and water, not necessarily water, but you feed and you look after a server, but containers you must herd. Is that the kind of herding containers? Is that the right terminology?
Yeah, basically, there was a container orchestration. So containers are usually orchestrated, right? You don't just start an individual container unless you're doing some testing. So you would start a whole deployment, and then all the containers should behave the same, and they should all have the same setting, and they can compensate one another. They can grow, they can scale with the application. So the idea is that you are not going to have a single point of failure anywhere in the environment.
I did have a customer once, I remember, and he used to have his chickens on his server in his office. And I thought, well, this is actually a good use case. They really liked how warm it would get, and he actually had nests and chickens sitting on them. Anyway, moving into containers, what recommendations would Aqua Security have for customers who are trying to prime their applications to be defended properly? And of course, we've like advanced now with AI and everything, but I'm sure there are kind of some core best practice and recommendations you guys would recommend.
Yeah, so one thing that's really important to understand is that containers caused a kind of whole strata of IT practice to basically disappear or become minimized, and that's ops. Right. So in the old world, you would design your piece of software. You would say maybe it's a Java application or a .NET application, and then you would ask ops to build your server. And they would build the operating system. They would put all the necessary components on that server, and then you would put the application on it, and that server would live maybe for a number of years. What happens with containers is that the people that design the application, those that build the application and put the container images that will eventually become live containers, have control over the entire stack, top to bottom, right? So the selection of the operating system, the selection of the base components, what goes into the application, even the base operating system version, are now all part of the application design. So when I talk to my customers, for instance, what I kind of tell them, the way I present that is that, an individual developer really didn't have any knowledge of what version of Bash was running on the server that their application would eventually run on. But now, because there is the component selection and the design of the application is now done when you're building the image, you do care, or at least you have an impact about what version of Bash, what version of the base operating system, what other components of the base operating system are going into the application. And unfortunately, development organizations got basically, that job got thrust upon them, and they were not ready for that, right? Because developers know how to write code. They really don't know how to design the operational status of an application. And that brings some of the security challenges about managing containers, and it also brings the onus on the development teams, the people that build and design applications, to make good selections. So the first thing that I would say is that when you're building an image for containers, the selection of the base image is really crucial. If your application does not need a lot of base operating system services, you might want to use a lean image. There are a lot of vendors, Google, Docker, many images. Alpine is a good distribution for a lean image that don't carry a lot of the superfluous components that you would have for full operating systems. So if you just need to run a small node application, or if your application component only needs to do one thing, just make sure that you don't put a lot of other things in that operating system, because these things can then just sit there and become a target for attackers.
Yeah, this is all about reducing attack surface, which we used to do in server hardening, on a more one-to-one kind of basis, and often you'd have gold images that you'd load up. But when you're talking about containers, you're not talking about 5 or 10 or 20 servers. You're talking about hundreds, possibly thousands of containers. So controlling your attack surface and your vulnerability space really seems like an important thing to get right at the early stages.
Yeah, absolutely. And one thing to remember is that once a container is launched, unlike a server, you're really not supposed to touch it. It really is not supposed to have any interactive access. You're not supposed to log on to a running container, which means that a lot of the software that you would have on it that service the administrator shouldn't really be there as well, like things like UserAdd, things like the password application, the thing that allows you to change your password. Those really don't need to be in a container, because nobody should be using them. And the only people that might use them are actually attackers that are going to use those in order to further the cause inside of your environment.
So are there tools that help you to view what your images are, so your templates for creating those containers, and then remove those vulnerabilities or those services that are running?
Yeah, so there are basically 4 ways to counter vulnerabilities in containers. Right? The first and basic thing is just not to have any vulnerable components. And of course, the more components you have, just statistically, you will have more chances of having more vulnerable components. The other thing to do is to just keep your components up to date. And again, that is very different from traditional servers, because in traditional servers, you would keep the application in place and you would just patch the operating system around them like you would do update to your laptop, from time to time without changing the fundamental software in your laptop. But with containers, you have to build a new image. So when you really don't never patch a container, you would build a new image with updated components, and then you would replace the running container with a new version of the entire container that now has the patched components, and hopefully your application does not persist data in that container, because that is another thing that containers are not supposed to do. And if all that works well, you will now have instantiated a whole slew of new containers that's supposed to do the same thing with updated components. The other two ways to deal with vulnerabilities is, first of all, to accept it. And we live in a world where there is no chance to get zero vulnerabilities anywhere. So the whole idea is to manage vulnerabilities, manage the risk level that the organization or the application can tolerate. So accepting a vulnerability, basically saying that it's okay that it's there. We might have some compensating controls, maybe on the network side, maybe on the runtime side. We can do that. And then the fourth thing, which is where Aqua really comes into play, is we can compensate for vulnerabilities and other risk areas by putting very strict runtime controls over the things that a container can and cannot do. And that will make it so that an attacker will not be able to further their cause inside of the container, because they will hit a wall. So reducing the number of containers that the application just uses in general is going to not allow attackers to live off the land, as we call it, but then putting more and more restrictions on what a container is to do and really tailoring it to what the application needs will allow us to run the application safely, even in a high-scale containerized environment.
And I think what you're describing, we often use the term shift left. So you're kind of minting in or pushing in security practices on the left-hand side of the cycle, rather than once the containers have moved into production. How are you seeing that evolving now in Aqua Security with the advent of AI? Are you seeing people using AI practices in the left-hand side of their pipelines? Is it impacting the number of vulnerabilities that people are seeing?
Yeah, so AI actually introduces a whole new category of vulnerabilities, right? If the vulnerabilities that when people think about vulnerabilities, it's either CVEs, so common vulnerability exposures, the system that we have to classify bugs in software that have security implications, or it is a vulnerability in the software design, so things like SQL injections and things that might be discovered by a web application firewall. AI brings a whole new set of challenges. It is how the model is resilient to prompt poisoning, how resilient the model is to the feedback loop between the model and the prompt of the users. There's also the selection of the SDK that you're going to use if you're going to have the application call out to an external AI model. So all of these are new components that we are really only seeing in the last year or so. And those have their own set of vulnerabilities that we need to manage and that we need to be aware of as we build our application, if it is an AI-enabled application.
That's really interesting in terms of where customers need to spend their time. So if you had kind of 3 tips for customers who are building or have developers or application owners who are really pushing for containers, what would those kind of 3 tips be in terms of things to do and things not to do, especially in a world where we have lots of drive for AI and cloud native databases?
Yeah, so the first thing, as we said earlier, is just use the leanest image that you can as your base image. Just do not put any components that really don't need to be there in the file system of your application. This is the one, and the differences are really stark. You can have a bloated image or a full operating system that can have maybe 500, 600 vulnerabilities that you need to manage and account for and be screamed at to fix. But if you use a leader image, if you use, let's say, an Alpine image or the UBI, the Universal Basic Image from Red Hat, it really boils down to the single digits, right? So the differences are really, really stark. So the first thing that I would say is use the leanest image that you can. The second thing is, and that's something that not a lot of people are paying attention to, is that images live in a registry. So the way that containers work, you would manufacture an image, you would put it in the registry. It basically waits there until something like Kubernetes is going to make use of the image. And because we are dealing with generations of images that build up the application, because each time we patch or make a change in the application, there's a new image generated. Those registries really become bloated, and we've seen in our customer base that customers have registries where for 2, 3, 5, 6, 7 years, nobody has ever deleted an image. That is also a problem because those get scanned all the time, and we get dinged on applications that really are not in use anymore. But also, attackers really love to have Kubernetes go into registries and pull old images and run them because they know that there are more vulnerables, because they know that there's more bugs in them. And because Kubernetes will happily run any image that it has access to, getting images off the registry after a year, after 6 months, right? Don't do it like on a daily basis, but if you have images in your registry that are more than 6 months old, really ask yourself, do they really need to be there?
Yeah, we see that a lot with we see that so much with containers and serverless as well. If you've got legacy containers and legacy, things like Lambda functions, for example, just letting those build up, and then you have to try and find out, well, is this actually still in use? How can we track that? Nobody wants to cause any downtime, but also you have vulnerabilities potentially increasing.
Yeah, and then my personal pet peeve is what they call lift and shift, which is, people want to run things in container. It's easier, you can really run them at scale on AWS and things like the Kubernetes services or in Lambda. And what they do is they take a complete server that maybe have lived for a number of years, take the entire disk, take the entire operating system, and then convert that to an image and try to run that in a container. And this creates a myriad of problems because a lot of times it actually forces you to run as a higher privileged user, because on a server, you in order to make use of all the operating system services, you really need to be root. So it kind of pushes you towards giving containers more privileges that they need. But then it also plays into the fact that you will have, 500, 600 vulnerabilities, a lot of superfluous components, a lot of openings for an attacker to, if they get the foothold with a misconfiguration or a vulnerability, or maybe even something that came through the supply chain, right? We've seen instances where components have been poisoned really on GitHub and been pulled in. They now have a complete toolbox that they can use to further a cause into the cloud. Containers kind of self-document, so they will tell you where their control plane is. And if you have all those operating system capabilities, then an attacker can really make use of those and attack your cloud.
Do you find when you're working with customers, as a company, Aqua Security, are you somewhat agnostic if they're using like a managed service, like let's say the managed Elastic Kubernetes service, versus say deploying natively on an EC2 instance? Is there, from a security perspective, do you recommend handing over some of the practices to the cloud service provider in that example? Or is it are you seeing the same behavior in both cases? Same problem, same.
Yeah, interestingly, right, Aqua actually precedes Kubernetes, right? Kubernetes is about maybe 5, 6 years old as an adopted platform for running containers. Aqua has been around since basically Docker started containers in 2015. So we've been through what was called the orchestration war. So when we started the company and thought of the methods and what we need to do in order to protect containers, the orchestration really wasn't a thing. So Aqua in its core can protect a container wherever. It could be Docker or Containerd on an EC2 instance. It can be in the Kubernetes services. It can be in Fargate. It can be in anywhere that containers are running. But over time, we had to get more capabilities that will help you manage the risk of those services, right? Kubernetes itself first of all, Kubernetes runs in containers, which if you think about it is really meta. And then Kubernetes also has hundreds of configurations that can go wrong. The cloud itself has maybe hundreds of thousands of configurations that could go wrong. So everything we do in Aqua is in the service of the workload, eventually the container. But in order to defend a container, you need to know where it's coming from. You need to know where it is. You need to know what the parameters. You need to know the environment that it operates in. And therefore, we also have the ability to look into Kubernetes, look into the cloud, and find the settings and the things that affect containers so that we can account for them as we do the defense on those containers.
That's so interesting because from a Kubernetes perspective or a Docker perspective, a lot of those containers are in a server, maybe on-prem, and they get migrated into the cloud. So is there a kind of a recommended way of of, I guess, streamlining that lift and shift so you have security mechanisms in place to reduce the attack surface and the vulnerabilities, and make sure you're looking at permissions as they migrate to the cloud. So kind of a model to stop you just lifting and shifting to get the job done.
Yeah. So, if lift and shift is taking a complete server, right, a monolithic old style server, and turning it into a container image, once you've turned that into a container image, and I would urge everybody to kind of look at the application, re-architect it so you don't pull it completely into an image. But once you have a container image, the nice thing about it is it contains all its dependencies, so it can run anywhere. So you can actually safely take a container image and run it, on a Docker server under your desk, and then migrate it into EKS, and then migrate it into Fargate, and it's going to operate in the exact same way. However, in each one of those environments, the container might have different properties and different access that it is going to inherit from the orchestration. So, for instance, when you run a container in Kubernetes, and if people have access to containers, just do a dump of the environment variables, and you will see, the IP address of the Kubernetes API server, basically the management plane. You will see the cloud labels. You will sometimes see cloud information. So those get inherited by the orchestration system. And when we look at how to defend containers, we also need to defend against attackers using that metadata that is just readily available to be read in a container in order to affect the orchestration system around it. So there's nothing wrong in taking a well-built container image and moving into the cloud, but just be aware that as you do that, the container might inherit more information, and we just got to be aware that that information is there, and it's really not protected as long as somebody has access to that container.
Great tips there. Great tips.
I loved your phrase there, orchestration wars. I actually hadn't heard that before, and I didn't realize Aqua Security was around longer than Kubernetes, which is actually pretty cool. Do you think people introduce unnecessary complexity? I mean, I sometimes amusingly feel when I'm talking to customers, they describe an application, and rather than describing the business capability, they go, and we want to use Kubernetes. Is there unnecessary complexity that sometimes is brought in when they're trying to re-architect, and how can that be avoided?
Yeah, so not every application should run in containers. We're seeing in our customer base, we're seeing kind of hybrid applications where there could be a kind of high capacity short transaction that might run in Lambda. It might transact versus a set of deployments that run in EKS that doesn't need to persist data but need to persist transactions. But then those will talk to maybe applications that run on EC2, which then persist data into either cloud storage or locally. So my advice would be, just instead of determining in advance how you're going to run the application, look at what the application needs. If this is a high capacity short transaction application, maybe function is what you want to do. If this is a application that needs to persist data, let's say you run an FTP server, for old timers, or something that needs to store files, a container is not a good use case for that, because containers are, Kubernetes, once it moves the container from one place to the other, it might lose the storage of the container unless you're using an external storage. So when you architect an application, think of yourself, what is the flow of the data? What needs to be persisted? What is the length of the transaction? How long do we need to sustain a transaction? And then you'll kind of get an idea of what is the right deployment mode for that component of the application. And applications, complete applications, end-to-end applications, could have certain modules that run in EC2 instances. They might have modules that run in EKS, and they might have modules that run in Lambda.
Just a quick reminder: if anyone's has questions on container security, pop them in the chat, and we can ask them live and discuss them.
And there's also been a QR code flashing up. Here we go, which I believe Tsvi is linked to an Aqua Security tutorial.
Yeah, it's linked into our information page about running generative AI safely in containers. But on the Aqua website, once you get there, we have our container wiki, which is a good source of information for containers and best practices. You have access to our knowledge base around how to safely run containers. And there are links there to various resources if you want to learn more about how to run containers safely or the capabilities of Aqua.
What do you think containers will look like 5 years from now? We've talked about the past. We talked about the orchestration wars, which sounds like a George or Martin book, by the way. We've talked about Aqua Security being around longer than Kubernetes, which I love. What do you think the next 5 years might look like?
So containers are now the primary vehicle to run AI-enabled applications and AI models. As organizations start to look into implementing their own on-prem, which doesn't mean in their building, but under their control, AI models for their own uses, the use of containers is only going to grow. Now, I've been long enough, even from the mainframe days and back in the 90s, people were telling us that mainframes are going to disappear. That hasn't happened, right? They have very, very long tail. I think containers are going to be there in 5 years. They're probably going to be orchestrated by AI-capable orchestration, which is going to be even more intelligent than what Kubernetes can provide. Hopefully, we will have a much better handle on the vulnerabilities in containers, but containers are not going away. They are now the primary vehicle to build applications, and I expect that to stay the course for at least a number of years.
I love your use there of the phrase on-premise. It's the first time I've heard it used, but you used it in the context of somebody actually, running their own model or doing their own training in a container, maybe in the cloud. But it's like this on-premise notion, we're doing it ourselves. Is that what you meant? Did I pick you up correctly?
Yeah, on-prem can mean different things, but it really means under your control, right? So it could be your application can refer to ChatGPT or Llama as an AI model. You can run a local copy of that. You can run a local copy of that in your own AWS account, or you can own the copy in your own data center. But the container is going to be the same container. It needs to be defended the same way.
Yeah, we have a similar model in terms of we bring the model to the customer in AWS services like Bedrock, for example. So we bring that into your environment and then allow that to access data, etc., rather than sending data to the model. That seems a poor security and governance model of operation.
Yeah, absolutely.
Well, I think this has been super interesting. Will you be at Reinforce, which is happening next week? Yes, next week, I believe. Any chance we get you over there?
I'm not sure that Aqua is going to have a presence in Reinforce, but we are always happy to engage with people that run services in AWS, and you can always contact Aqua if you have a need in that respect.
Awesome. Tsvi, it's been awesome to have you. Thank you so much for your time. Really, really great to hear about the things happening in containers and security and how our customers can start to implement better security and more governance around that. So thank you very much. Up next, we have another amazing guest. Who have we got next, Margo?
So up next, we have HashiCorp, and it is Cole from HashiCorp. And I just want to call out in the comments, Tsvi, we're getting, we need InfoSec more than ever. Great to hear from you all. And very informative session. Thank you, Tsvi. So you have some fans in the comments. We haven't been great at multitasking, reading out the comments. You were so interesting to listen to.
We're going to need to get Tsvi back on, and we'll do a version 2. So get your questions in, and then we can maybe we should do that. Maybe we should start to gather some questions, and we can run another Security Live episode answering those questions. Maybe we need to do that.
Anytime. Thanks for having me this session, and I hope to see you again soon.
Excellent.
Awesome.
And please join us again after the break, where you can go make your cup of tea, and we'll have Cole from HashiCorp.
Good morning, good afternoon, possibly good evening. We are AWS Security Live. My name is Rob Hale. I lead AWS's partner security business. As ever, we are going to talk about security topics around security partners, how we're working together to solve for challenges that our customers have. I am joined, as always, by the brains of the operation, my co-host Margo.
Hey everyone, my name is Margo Cronin and I'm a security and compliance specialist SA with AWS.
So I said you were the brains of the operation, and everyone can now understand why. So, so where are we next week? We're obviously you're in Switzerland today. I'm back in the UK, but we're both in the same place next week. What are we doing next week?
Yeah, so next week we will be streaming live from Philadelphia for our Reinforce conference. And so we'll have 2 days. And my producer, the producer won't be thrilled at me, but I haven't checked the show schedule yet. So I can't tell you exactly how many shows we're streaming over the 2 days, but we're pretty much streaming the whole time. There's going to be a whole load of guests. I love the live format. It'll be my first live format this year, but I think you've done a few live formats already this year.
Yeah,
You've
I
been in the
will
front
say.
line.
Yeah, when you click that link, brace yourself. So, so we will be live for 2 days. There'll be a number of hosts, myself, Margo, and others, and we will have almost back-to-back shows all day on both days to bring you loads of different security use cases, loads of different guests. It's going to be amazing. We might need coffee, a lot of coffee.
We start very professionally, but it kind of descends then, like into mayhem and jokes as the days go. We try to leave
Surely
it
not.
the whole time, but it does descend a bit.
We will also have games.
Will we? Oh God!
Oh yes.
I'm still recovering from last year's "What's in the Box."
Yeah, our production team like to challenge us with some interesting games. So you guys can join in. So as ever, if you're joining us, put in the chat where you're from. We know we have viewers from all around the world, so we'd love to hear from you. So today we have. Or for this episode, we have another amazing guest. So we have Cole Morrison from HashiCorp. If you don't know HashiCorp, you probably should do, but they are an amazing infrastructure security company. So they help customers to automate multi-cloud and hybrid environments with infrastructure lifecycle management and security lifecycle management, so you can run faster but securely. So let's welcome Cole onto the show.
Hey.
Hey, Cole, how you doing?
Pretty good. Yeah, y'all can hear me okay?
We can
Loud
hear
and clear.
Yeah.
Where are you coming to from today?
Well, so y'all were mentioning like, oh, we're in Switzerland and UK. So I was just in UK, then in London for Hashi Days, our conference, and now I'm still not even home. I'm in DC, so I'm using a friend's office. So we're all kind of scattered, which is interesting.
That's awesome. Borrowing a friend's office. So what
Yeah.
can we see in the background? Is that?
Oh, let's not call it out. Let's not call it out. I had to make sure that I said the plushies are not mine. They're not mine.
I just need to tear up my question list. My first 10 questions were all about the plushies.
Oh, okay, yeah. No, I would just be like, I would be making up things about them. So no.
I think it's quite cool because we're continuing on with our theme, I think, of shifting left. And do you want to introduce and give context around HashiCorp and how they help AWS customers and HashiCorp customers shift left?
Yeah. So I guess that in a nutshell, well, Rob kind of gave it. Everything infrastructure and security lifecycle management, which is a juicy mouthful to say. You build your stuff, you deploy your stuff, and then that's right, everything else that happens from that point forward. One of our ambassadors had this fun stream. So Patu Arvizu, he called it the Day 366 elephant, and it was the whole we all worry about our certs until day 366, and then everything goes to chaos, right? Because we have to think about what happens beyond, all of the different life cycle of how those things happen. So across our products, the one that we are most well known for, so well known that people forget that there's a company behind it sometimes, is of course Terraform. So infrastructure as code, right? The second big heavy hitter would be Vault, and that's very relevant to this stream. That's our centralized secrets management tool. And then of course we have everything else in between, from I gotta count count them all out which is funny because for folks from AWS, like, you got nothing. We got to count so many. It's like you got to count a whole 8, Cole. Like, come on now, right? So we have our machine image management in Packer. We have our service mesh in Console. We have our orchestration, workload orchestrator with Nomad. And we have our secure remote access with Boundary, and then our IDP, our internal developer platform with Waypoint. And of course, not to forget the very first product we ever had, and my favorite question to see how much of an OG the HashiCorp users are, is Vagrant, right? So that was the whole Vagrant Up development environment with VMs, and yeah. So
Awesome.
Go ahead. Sorry.
I was going to say that's awesome, and actually, I love the fact that you almost have Terraform as an infrastructure as code as kind of an afterthought. Actually, that's the basis of good security and frictionless security, making security the easy option. And we spoke about that in the previous stream as well, around just like containerized images, for example, and infrastructure as code, making it secure and repeatable, and then that has a massive impact on security.
Yeah, and what's interesting too is from the infrastructure as code part, because we're saying infrastructure and then the word code, the word as doesn't really have anything to do with anything. But because we do those, everyone tends to say, well, it's about just the infrastructure, it's about building stuff. You talk to a developer and they're like, ooh, modules? Like module, that's like an abstraction for speed. I can go faster and I can make a singleton that no one except me understands. No, it's kidding. I'm not calling anyone out there. No, but the reality is when you bake down an abstraction and you say, okay, I'm going to put together a simple, say, VPC module, right? And inside of it, I'm going to define so many things. We're actually doing more than making speed. We're baking in standards, right? We're baking in things that we've said, this is okay. This is how we're going to do it. This is how it will run every single time. So those container images that you're creating, the infrastructure's code that you're putting, the policies that you're writing down, those are all work towards, what you said at the beginning, towards that shift left. If we shift it towards the blueprint, right? Then we can solve it at the blueprint until we've made 100 identical faulty buildings and trying to figure out all of it there, right? So, yeah.
So before I ask
Awesome.
my question, I do need to say that there's like some tears in the comments about the fact that there are no HashiCorp plushies.
Yeah, this is customer obsession here.
The marketing department are not going to be pleased with you.
Oh gosh, so now we're asking for HashiCorp plushies. That's
But no customers are asking for HashiCorp plushies. So and we've got viewers from Los Angeles, from Spain, from India, from Ohio. I'm not sure where the HashiCorp plushies. You can tell I need another coffee, right?
You have
Maybe that's the brand, HashiCorp.
HashiCorp. Wow, that's
In your introduction, you mentioned something super interesting, which was, this day 366, right?
Yeah.
So this is when like kind of all the certs timed out and people were getting errors and like maybe they were going to their SOC or maybe something just wasn't working, not responding, etc. But of course, we have big changes coming up now in the industry in 2028 in March, I believe, where day 366 will be brought down to day 48.
48. Yeah.
47. So it's day 48 where all these errors will throw. So are your like secret lifecycle management tools changing and evolving to support that, or what can customers expect to see there?
Yeah. So first off, what's funny is I remember when I first heard the whole 47 and then 48 day, I was like, I was like, that's funny, man. You're just kidding. It's like, no, seriously, look at this. Like, oh, I was like, okay, well, now my poor little blog's gonna be bugging me every so often because it's a thing in our professional setting. We use the best of the best, but then we go and we stand up our personal stuff and it's just some like Ubuntu 12 instance that's barely trucking along. But the reality is that on our side for stuff like Vault, public key infrastructure is something that we've had for a while, and we've pushed the concept of dynamic secrets, and we pushed auto certificate renewal as something that you can just do, right? You have your own root CA, you plug in Vault as an intermediate CA. You can have it as a root CA, but most companies tend to have their own root. You plug it in as an intermediate CA, and it gives you the power of Vault to just rotate these certificates whenever you see fit, right? And for all the different applications that are dependent upon them, it's not something that you're going to have to go do manually. It's something that you can have set up. You can have the Vault default agent do it. You can have the VSO do it. There's all sorts of different ways that you can enter into it and make it so that this problem is just something that's already in place, that's already happening. And if you're feeling really go-getter, you can make it happen even sooner than every 47 days, right? So, yeah.
Cool. And we have a QR code just gone up here, which will link listeners to.
That, if it's the updated one, that should link to the policy-driven infrastructure. Let me read out the full thing. The policy-driven infrastructure, right? So AWS and HashiCorp's approach to cloud governance. And so that is even more so on that side of the shift left stuff with the policies code. Well, what's funny is coming from software for the longest time, I just call it a unit test, an integration test. And then the more I started moving into DevOps and then DevSecOps, the more I started realizing, oh, y'all call it static analysis. Y'all call it policies code.
Yeah.
Yeah. And it just keeps going and going, but it has such a big impact. And what's funny about these types of things, like what you just talked about with these auto cert renewals, with policies code, is there are these very tiny defaults. Sometimes they can take some stuff to set up, but the importance of them is you set them up now, and it pitches the degree of your infrastructure just maybe like 2 degrees to the right. You know what I mean? Metaphorically, or I think that's the right word for that. And then you fast forward a year later, and it's in a different place, right? It's better. It's more secure by default. All of the infrastructure that's been built upon it is more secure because it's had to be, right? You have policies saying no open S3 buckets. Like, come on now here, tag all your instances, all these things, and those changes compound over time. Whereas if you don't do those things, right, it doesn't scale your intentions. Your defaults don't scale like, oh, I wanted it to be secure. Like, it scales whatever you've got. So, if you have chaos, if you have bad defaults, it's just going to scale more of those. And you're going to look up and be like, oh, why is everything on fire? Well, it's never the result of some big dramatic, it's generally just some very easy to forget decisions that you made a long time ago, or some sort of systems you set up that you fast forward and now all the problems are there. So.
That's interesting because you mentioned earlier things like dynamic secrets or dynamic credentials, but actually when you're dealing with infrastructure and code and making templatized environments and images, things like secrets get published an awful lot. Static secrets. How do you actually tell when your developers are starting to insert static secrets into their environments?
Yeah, well, generally they start avoiding eye contact, so something's up, right? It's like, hey, Rob, so what was it that last commit? And Rob be like, oh, it's good. It's like, okay, let me go check through that. Yeah. So in terms of how do you check, that's an interesting question, because we can set strong defaults at the beginning. We can shift left as far as we want. But that doesn't mean we've caught everything. And in fact, that's going to be part of the remediation to say, okay, something did slip through. How do we go through that? Well, there are a ton of secrets analysis, right, system scanning tools out there. Everything from, partners that we have with like Prisma Cloud to Wiz to also, well, on one of our own tools, Vault Radar, something that we have that can look at these different data sources and scan continuously. Now, it's one thing to tell it to scan for specific known secrets, but then there's other things such as with, I'm not going to keep pushing any type of product or anything, but using entropy analysis, right? You can see how much does it look like Rob just went through and did like 50 coin flips and then constructed and then just sort of switched a couple of letters. Like, that's probably a secret, right? Let's report those back. And once we've reported all those back, let's take some steps to remediate them. So that means maybe putting them into a secret sync. That certainly means taking them out of the actual live code base, which if it's made it that far, we have some other cleanup to do. But then, of course, the step becomes, okay, that happened. We've alerted everyone. We've taken it out. We've put it into the sync. Now let's go all the way back to the beginning. That's another default we need, right? That's a place where we need to change the policy. That's a place where we need to take a module, make it a little bit stronger. That's where we need to, yell at people more. Like, I don't know. We got to do it somewhere over on this side before that happens again. So, yeah.
I just like to add, I add seasoning to everything, so there's plenty of salt.
Okay, yeah.
In the comments, someone is asking, what about compliance at scale? That the speed of development is so fast, everything you've described has actually enabled that speed. And what at the same time they're trying to, align to standards and frameworks and the governance people and the EU AI Act.
Yeah. So that's I think when we brought up when we were scoping on our talk, the reason why I think collectively we all kind of agreed, like, okay, let's talk about the shift left side. It's a bit dated perhaps. I'm sure it's not as new and big of a term as it used to be. The same with infrastructure as code, also not, that's been around forever at this point. And the same for secret scanning, like after the fact. How do we do intrusion analysis? Those things is because it kind of reminds me when folks ask me, like, well, how do I build in the cloud? It's like, I just opened up AWS and there's like 50,000 services. I'm just kidding. There's not that many. It feels like it. But the reality is, if you understand the base primitives, right? Compute, storage, networking, IAM, security, which is kind of a catch-all since that's so many things, you can build so many things. Those are the primitives. Well, similarly, for this question with compliance at scale, the things we've mentioned are how you can get really, really far, right? You set up policy as code. You say all of the policies. Now, everybody knows we need policies. Agreeing upon which ones you do have to have, that's a little bit political, and you'll have fun with that. But once you've agreed upon these, setting those up such that if you're doing everything through infrastructure as code, which hopefully you are, right? If you're codifying as much as you can, which hopefully you are, then shifting left to guard against those things before they get out, that's a big step towards compliance. And everything from that point forward becomes, well, am I auditing it? Well, if it's an infrastructure as code, every single commit is something you can audit, right? And then am I checking it after the fact, which is that final tool that we talked about. So he said, I'm curious about how resources deployed in different CSPs are controlled and assessed. And that kind of reminds me of this question that I have around infrastructure as code too, that I'll get to, like, well, if I learn this, do I know all the CSPs? You don't. You really don't. Just like if you learn one compliance set of standards that doesn't clear you for the other ones, you have to figure out what theirs are going to be, how to speak to each of them. And quite frankly, it's going to be a little bit of a journey you're going to have to take for all of them. So what you set in place for AWS, sure, the first principles are going to be the same. You will have to apply those to a different CSP and pretty much, but you'll have to express them in a different way. So
Yeah, and this is the same, I guess, with multiple environments from anywhere. If you've got multiple different environments with different controls, different frameworks that are based on different compliance frameworks as well, you're going to have to learn how to be secure and compliant on each one of those, and know how to actually measure that as well, because that's another difference between different platforms is, how do I get that compliance data out? Not just about are our people doing it. So that's an interesting play on shift left, because developers want to move fast, and one of the biggest issues is that when developers are moving fast and security isn't the easy path, well, they're going to start to do things that are maybe does help them to move fast. They can get that new commit out and make their deadlines, but security might be reduced or compliance might be reduced as a consequence of that. So, how do you help in terms of, or how would you suggest customers help their developers to do the right thing, so to make security the easy route when they're building environments?
Yeah, that's a good question. And it's such a good question too, because that is when things start going down, right? It's like it's the same gripe I'll hear about internal developer platforms. They're like, it's not self-service if I still gotta Slack you. It's like, you're not wrong. That's a good point. Well, similarly for security, the strong default's in place, right? However, the question then becomes like, well, yeah, I want to move fast, and my platform team, they've got all of these cleared modules, but they don't do what I need them to do. Right? They're too stuck in one pattern. I need something that's more fit to my case, more fit to my application. So what do? I'm going to fork your module. I'm going to change it. And then someone's going to fork that. They're going to change it. And then that's going to get changed who knows how many times. And then later on down the line, someone's going to pull one of those and it doesn't work anymore. And now we have an entire incident, right? So it's kind of funny how like you catch yourself as a developer trying to work around the things that don't work. This is when I paint these things in a continuum, I tend to actually put policy as code. I know you're like, Cole, you're still talking about policy as code. It was over years ago. But the truth is it's an easy way to enforce compliance, right? While still opening things up, because they're not nearly as confining as a module that says this is all you're getting. These are the only things you can change. Policy as code just says everything but this, right? Like everything but these things. Just add these couple of things there. And this actually helps out because it actually is a good segue, because we actually, and I say we, I mean AWS and HashiCorp, we actually partnered recently and put together an entire suite of pre-made policies, right? But they're based on the Center for Internet Security Foundation's benchmark v1.2, 1.4, and 3.0. I got it. They're all there. All of those. All right.
Yeah, exactly.
Yeah, and you can actually go in, just click a few buttons, have every single policy that you want that are all cleared, vetted, and written for AWS. You can drop those in front of your infrastructure's code, and you're good to go. And that's just the ones we partnered on. Amazon, y'all have added some other ones to the registry where there's like 219 plus different policies. And so that's something in terms of speed when you're looking at, okay, how do we enable the developer to go fast? It's like, well, first up, we should probably help us go fast. And part of that is, let's get these policies in place as soon as possible, and now we can breathe a little bit. So,
have you considered renaming policies as code to plushies as code? I'm sorry. Okay, move back to security. Actually, and there's some people in the comments, and they're looking to improve their Terraform skills, by the way. So I don't know.
Some vouchers.
Yes. Would you accept plushies
instead of vouchers?
That's a big question, maybe. This is going to be a theme. Sorry.
No.
Do you have customers asking you or concerned about concepts like harvest now, decrypt later, and these kind of coming down the path again, back like similar digital certs, but further again, 2030? Like, what if somebody has my ciphertext and at a later stage can then decrypt it, that they're that organized?
Absolutely. In fact, what's funny is when we talked on our prep call, we kind of brought that up, and the more time comes on, I feel like it was foreshadowing, because at Hashi Days London, we had a whole group open up on us about that. And they were
really?
They were just like, well, hold up, these are all the new algorithms coming up. You have the PQC, ML, DSA. I don't ask me to tell you the exact words for that.
And then Psych, or maybe I need to double check myself as well. Maybe Bike and Psych were for them, but then weren't approved. But yeah, I think August 2024, they defined the standards and signatures, or keys and signatures. And I think there are 2 more coming now again. So yeah, it's coming up for me as well, right? Like customers were asking about this. What were they asking in London?
Yeah, the most, well, there's 2 things. The first one was, well, hey, do you all support it? The question is, yes, our transit secrets engine, we have MLDSA, so you can send up very quickly, and since it's transit, it's our encryption as a service one. So generally, when you ask about enabling developers, first up, if they ask to keep an asymmetric key in their app, I'm gonna tell them no. But if I ask them, then it's probably after hours, and I'm just trying to close out the thread. But regardless, we would prefer to let them work with their infrastructure and everything else how they're used to. So that is an endpoint, right? So transit secrets, it lets you hit an endpoint, receive with plain text, get ciphertext back, do what you want. If you need to decrypt it, hit the same endpoint, decrypt it, get the plain text back. It means you don't have to manage the key. It means we can rotate the key. Obviously you're not going to be doing this flying over the public internet necessarily. However, it does give you that capability, and the MLDSA, that's one of the algorithms we just added, which is of course quantum safe. Now, so that's always the first question. The second question was, well, why isn't everyone just all doing those, right? Like, why isn't everyone just moving to that algorithm now, right? And that's a really good question. In fact, I would love to hear your all's perspectives on that, because that's one where it's like, well, infrastructure as code was also pretty obvious, but not everyone's moved to it, right? So what is it, right?
Yeah, so you mean like why are people still on RSA and ECDSA and all of this?
Yeah.
Honestly, I think it's related to governance and how large organizations are, and actually trying to, and it's interesting, I'm really going to age myself now, but when I was coming out of college, there was a plethora of Y2K projects, right? Like systems, it was 1999, all these systems were switching over to Y2K and nothing's going to work. I kind of feel we might have the same kind of fear, uncertainty, and doubt coming into this next wave of because so much is encrypted now. And I would feel many of our customers mightn't know the real estate of their data that's encrypted, because 10 years ago it was for the nerds, but now, to align to the GDPR best practice, it's like encrypt everything, right? And we've just gotten a link actually in the chat regarding your GitHub HashiCorp policy library. Somebody has very kindly shared it for anyone.
Thank you.
Thanks, Pablo.
But yeah, that's my 2 cents. Why it's not like why people, and while we're being asked about threats, we're not really being asked about support for signatures, etc. yet. What do you think, Rob? Have you?
Yeah. I get so we get a lot of questions, a growing number of questions around post quantum safe measures and how to adapt policy and encryption standards. A lot of it, as Margo said, is it's kind of what we've always done. So our governance and our compliance standards are what we did. When we were last forced to change. And so you mentioned, Margo, earlier around Y2K. That was a fixed date. So everyone knew this was the date and you had to go and do something now. And lots of people were doing stuff, as we know, at 11:59 and, panicking and, seeing what's going to happen or not, as the case may or may not be. But the thing about post-quantum is we don't know when that's going to be. We have NIST standards now. So there is some actual, kind of rigor around what is probably possible and what isn't possible. So the standard advice is don't use inherently weak ciphers. That's a so if you're using a currently strong cipher, the chances are it's still going to take an inordinate amount of time. And as Margo knows, we have some super intelligent, super cool rocket motors of people who just look at crypto. And that's all that they do. And so they do actually quite a lot of these. I brought them into a few customers where they wanted to run workshops around post-quantum. And it wasn't really a do this, this is exactly what you need to do. It's more of a, well, look, what's the threat? What's the reality? And what measures can you take to mitigate that in the future? So, if you're still running RSA 128, probably want to start updating your policies and your implementation. If you're running AES, in any decent cipher length, then actually probably that risk is far less. So I think the problem with quantum is that people don't, there isn't a defined date of get this done by this time to this standard. And that's what people are afraid of. And so, I think education is a key thing. And it's why the NIST standards are really, really important, because at least it gives people guidance around things that they should be looking at.
That's such a good point. And it was kind of the hard thing to communicate, right? It was, well, they do know, but for some of these companies, for some of these customers, I hate to say it, but until they have an existential crisis, they ain't going to change it. If it's there and it's working, it took a long time to just get there to get it to work. There's a lot of things that you have to go through to make those changes. There's a lot of switching costs, right? And there's also just the fact that, these are the first set of algorithms that have come out. How are those going to change over the next few years, right? So, yeah, I feel like I sort of dodged one here. We didn't say AI once until right now.
You need to work for that.
Oh my God.
Hang on, and you left it until right at the end to mention AI. You realise how
We
dangerous that
nearly
is?
had a whole show about AI. It was
Our
like,
producers are saying, "Oh my God, they've mentioned AI now."
Oh no, yeah. No, I heard a joke recently, which was from one of my colleagues. He was like, I see a comment in there, stare. Yeah, I heard a comment recently. It was very funny. It was like, agentic. Oh, you just mean microservices? Because pretty much anywhere you hear agentic, you can just say microservice. It's like, oh, that's good, because that is. It's just another okay. Yeah. So there's your AI bit.
Well, I think we all need to keep an eye on the HashiCorp marketing pages for the renaming of policy as code to plushies as code.
My.
HashiCorp is coming soon.
Yes, exactly. PlushyCorp, plushies as code. It's just going to be a complete rebranding. HR will want to speak to you, Cole.
Yeah, I'll either get a raise or I'll get something else.
You'll get a plushie.
Yeah, I'll get a plushie either way. Yeah.
So we're gonna be at Reinforce next week in Philadelphia. We'll be live. Are you guys joining us for Philadelphia?
HashiCorp will be there. I was actually on the docket to go until just a couple weeks ago, and I had to back out. But you'll have plenty of people there to rant to you about policy as code.
We'll look out for the plushies. Thank you so much, Cole. It's been amazing having you, and thank you very much to Margo and our amazing viewers. So we hope to see you next week. We're Security Live.